Tesla is currently finalizing a major hardware upgrade for the Optimus robot, expected to be completed by the end of this year or early next year. This step is crucial to enabling the robot to efficiently perform a wide range of household tasks. Precise design is essential to ensure smooth, functional movements, saving users time and effort. But how will this new structure improve Optimus's performance? This development also serves as an incentive for us to continue bringing you relevant content about the Tesla bot, the brand's electric vehicles, and the latest industry news. Regarding Optimus's power supply system, Tesla is using its well-known 4680 battery cells to power the robot. While this choice makes sense from a capacity perspective, some question whether it's truly the most ideal option for a humanoid robot. Although the robot's body has enough space to accommodate these larger cells to reach the 48-volt voltage, considered safe for human interaction, the system needs to use around 90 cells. The company announced that the total battery capacity is 3 kWh, which allows the robot to operate continuously for approximately 12 hours in a domestic environment, performing tasks ranging from simple tasks like moving around the kitchen and cleaning the living room to assisting with child care or elderly care. After this period, Optimus can return to the charging station on its own and, in about an hour, be ready to operate again. Because it doesn't need rest like humans, it can operate throughout the day, as long as it receives timely recharges. The choice of 48 volts isn't random. It's a voltage level that reduces the risk of shock in environments where there's close contact with people. To ensure more stable operation and redundancy in the event of cell failure, the Optimus's power system will likely be modular, with multiple 48-volt battery units connected in parallel. This modular design facilitates component replacement, increases safety, and improves overall performance. Each 4680 cell delivers about 26 ampere-hours, and the combination of 48-volt modules is sufficient to reach the required 2.3 kWh. If Tesla had opted for smaller cells, such as the 2170, with about 5 ampere-hours, approximately 10 modules would be required, which would make the system more complex, take up more space, and increase costs. Therefore, it makes sense to continue using the larger cells, especially considering that Tesla has complete control over the production of these batteries at the Gigafactory in Nevada. In factories, the scenario changes. The robot will need to perform much more demanding tasks than just cleaning the house. It will need to carry heavy objects, tighten screws, and perform component inspections, all of which will place greater demands on the battery. Even so, thanks to fast charging technology, Optimus can get enough power to continue working in just 30 minutes. Tesla could also adopt a rotation system, where some of the robots are in operation while others recharge, thus ensuring a continuous flow on the production lines. A very interesting point is that Tesla may be implementing an energy recovery system in the Optimus robot. In practice, this means that when performing movements such as lowering objects or moving slowly, part of the energy generated can be reused and returned to the battery. This technology helps extend operating time without the need to increase battery capacity. Furthermore, Optimus's battery management relies on artificial intelligence. This allows the robot to adjust its energy consumption according to the task's demands. For simpler tasks, it consumes less, and for more demanding operations, it delivers more power. This energy flexibility represents a significant advantage over competitors like Figure AI or Boston Dynamics, which still rely on more traditional battery systems. In the future, Tesla may also test solid-state batteries in more advanced versions of the robot. These batteries are smaller, lighter, have higher energy density, and run cooler. If this technology is adopted, Optimus could operate for up to twice as long without gaining extra weight, something extremely useful in industrial or continuous duty environments. Although there are still discussions about the use of 4680 cells in the robot, considering Tesla's strategy and its internal battery production capacity, this choice proves to be technically sound and economically advantageous. As for Optimus's charging system, many initially assumed it would use the same connector found in Tesla vehicles like the Model 3 or Cybertruck. However, the reality was different. In a video released by the company itself, the robot features its own charging station with a minimalist look and straightforward mechanics. A curious detail is that when the battery charge reaches 15%, Optimus automatically stops its activities. The LED on its head lights up red as a warning, and its navigation system activates to locate the nearest charging station. What surprised many people was the position of the connector. It's located on the robot's back, not on the sides or near the legs, as previously speculated. This requires the robot to use its cameras and visual sensors with extreme precision to locate the charger and position its body correctly for accurate connection. The process must be agile yet gentle to avoid damaging the power input. Tesla clearly invested heavily in this mechanism, as even small misalignments can prevent charging or wear out the connector over time. Once fully recharged, the robot's LED turns green, indicating it's ready to resume its functions. The robot disconnects itself and resumes operation without any human assistance. This entire process occurs autonomously, as if it were an exemplary employee who knows exactly when it's time to rest and when to return to work. A special highlight of this charging system is that it doesn't just send power continuously. It's controlled by advanced algorithms that regulate the electrical current, based on factors such as battery temperature, time of day, and the robot's usage history. This ensures fast recharging without compromising battery life and maintaining stable performance when it's back in action. This automatic charging system is very similar to the plug-and-charge model already used in prototypes like the Tesla Cybercab, but now adapted for a humanoid robot. A significant advance in terms of autonomy and efficiency. Imagine a scenario where Optimus roams freely through a home or factory, locating charging points built into the living room wall or hidden in a corner of the warehouse, plugging in to replenish its energy as naturally as a person drinks water when tired. But the robot's system goes far beyond simply finding a charging station. It incorporates an advanced concept of collective learning. Just as humans share information in messaging groups, every time an Optimus learns something new, whether it's avoiding an obstacle or improving its movement in tight spaces, that knowledge is instantly passed along to all the other robots in the fleet. In other words, each individual advancement benefits the entire network of robots, eliminating the need for each one to go through the same situations to learn. Thanks to this collective learning capability, if a robot on an assembly line in Texas encounters a new challenge and solves it, minutes later, another Tesla robot in Berlin or Shanghai will also know how to handle the same situation. Tesla calls this collective learning, a form of decentralized artificial intelligence with rapid, real-time updates. Today, no other company can achieve this on this scale, mainly because Tesla controls the entire infrastructure, from the hardware and computer systems to the real-world data. With this constant exchange of data, the robots share movement maps, reactions to environmental stimuli, and even specific strategies for specific tasks. This transforms Optimus into more than just a functional robot. It becomes a living part of a constantly evolving intelligent network. This system becomes even more impressive when we consider the thousands of units working side by side in Tesla's factories. Each robot has a specific function, but all act in coordination, like a perfectly synchronized team. In practical operations, it's possible to imagine hundreds of Optimus working in shifts, without needing to stop for rest, without drops in productivity due to fatigue or distraction. When the battery level is low, one robot simply steps away to recharge while another takes its place, maintaining continuous and efficient production. This process occurs silently, with extreme precision, and without the need for human intervention. The charging system's data, combined with the autonomous adaptability, are not just technological improvements. They represent the foundation of Tesla's vision for a truly autonomous robotic workforce. It's the beginning of a new era in automation, where machines not only execute commands but also learn, adapt, and evolve within a living, intelligent network. Another notable advancement in Optimus Gen 3 is its ability to communicate with humans. Elon Musk confirmed that this new generation will support voice communication, something missing from Optimus Gen 2, which operated silently and with limited interaction. Now the robot can tell stories, offer advice, and hold everyday conversations, making it not only easier to control, but also closer to becoming a true everyday companion, a feat most current robots are still far from achieving. Optimus Gen 3 also features a 7-inch touchscreen installed on its chest, serving as an accessible interactive interface. The voice command system supports up to 15 languages and boasts 95% speech recognition accuracy. Furthermore, the robot can interpret body gestures with up to 90% accuracy, allowing it to effectively understand body language. This functionality is particularly useful in home or healthcare environments, where understanding both user speech and gestures is critical to providing an efficient and safe service. This feature set gives Optimus a clear advantage over competitors like Digit or Figure AI's robot, which so far focus primarily on mobility, but fall short when it comes to human interaction and communication. Optimus Gen 3 goes far beyond simply understanding commands and responding. It can adapt its behavior in a personalized way, thanks to integration with advanced artificial intelligence models. This technology allows the robot to modify its tone of voice, speaking style, and even posture according to the user's profile, taking into account age, context, and even the person's emotional state. With the elderly, for example, it can adopt a softer, calmer voice, offer reminders about medication schedules, or tell old stories to provide comfort. With children, its tone becomes more lively and playful, taking on the role of storyteller or play and learning partner. This level of customization far surpasses what virtual assistants like Alexa or Google Assistant currently offer, positioning Tesla as a leader in interactive robotics for personal use. This transforms Optimus into not only a functional assistant, but also an emotional companion, a sensitive caregiver, and a connecting link within the home. In a global scenario where the elderly population is growing rapidly, especially in developed countries, the demand for empathetic devices that offer support and human interaction is also growing. Optimus can assist with health monitoring, provide real-time reminders, and alleviate social isolation by becoming an accessible companion for conversations and interactions. For children, it can function as an interactive tutor, combining learning with fun, a significant advancement in the field of personalized digital education. Meanwhile, the competition still has notable limitations. Figure AI's Figure 01 can already walk and handle objects, but lacks a verbal or behavioral communication system. Boston Dynamics Atlas impresses with its agile and complex movements, but it wasn't designed to communicate with humans or understand their emotions. Robots like SoftBank's Pepper can even communicate at a basic level, but they're limited to pre-programmed responses and can't adapt to the profile of their interactors. Tesla, meanwhile, leverages its vast artificial intelligence infrastructure, built on billions of miles of data from autonomous driving, home cameras, smart devices, and image recognition technology, to create a robotic platform with human-like learning and interpretation capabilities, something no other competitor currently offers. In addition to communicating, Optimus Gen 3 also serves as a smart home control center. Fully integrated into Tesla's home ecosystem, it can operate a variety of devices and systems: lighting, climate control, locks, automated curtains, heaters, security cameras, and even energy management via Powerwall. This transforms the robot not only into an interactive assistant, but also into the brains behind a fully connected and autonomous home. This transforms Optimus into a smart, context-aware assistant, capable of automatically closing windows when it starts raining, opening curtains at sunrise, and issuing alerts when it detects unknown people. This integrated vision goes far beyond what current competitors offer, which typically focus solely on mobility or isolated reactions. From a socioeconomic perspective, the launch of Optimus Gen 3 represents a revolutionary shift in how we approach work and personal care. If Tesla can produce around 10,000 units per year and reduce the cost to less than $20,000 per robot, the deployment of a few million units could spawn a trillion-dollar robotics industry, spanning sectors such as healthcare, education, commerce, and home services. A robot capable of intelligent communication, emotional sensitivity, and task efficiency has the potential to profoundly transform the structure of the labor market, especially in countries facing labor shortages. Optimus Gen 3 isn't just a device that obeys commands. It represents a new form of human-machine interaction, acting as a digital companion that listens, shares, demonstrates empathy, and offers highly personalized, needs-based assistance. This level of interaction makes it ideal for applications that require delicate human contact, such as psychological therapy, support for people with autism, and care for individuals with disabilities, areas that demand complex emotional and behavioral responses, something that most existing robots cannot yet provide. In everyday life, Optimus Gen 3's flexible communication also extends its usefulness to household tasks. While mopping floors, doing laundry, or cooking, it can hold conversations, receive new instructions, or react to changes instantly. For example, if someone asks it to stop cleaning and get something from the refrigerator, the robot responds promptly, without the need for the user to pause or give manual commands. Additionally, gesture recognition allows it to understand signals such as stopping, changing direction, or helping to carry heavy objects, providing a more natural and fluid interaction. This functionality reduces the need for constant user supervision, as the robot can report task progress via voice or touchscreen, keeping the user updated without having to manually check. We truly appreciate your participation and hope this video provided moments of relaxation and learning. If you enjoyed it, be sure to click the like button and subscribe to the channel to become part of the Techno Creator family. Turn on the bell so you don't miss any of our incredible updates. Your feedback and time are very important to us. Thank you so much for watching and see you soon. Until then, take care and have fun.